Dear students, in the last class we discussed about the concept of limits. What is limit? Why we need this limit? In detail, with live example in day-to-day life. In two sessions already I discussed about the limit. Today, in this session, I am going to share about the concept of continuity. Okay, in this session, let us discuss about the continuity. In day-to-day life, we are using the word continuity, discontinuity. As I said in the previous sessions, whatever we are going to learn, the subject, we should always link with our day-to-day life. ಓಕೆ ಕಂಟಿನ್ಯೂಟಿ ಅಂದರೆ ಯಾವುದೇ ರೀತಿಯಾದ ಅಡಚಣೆ ಇಲ್ಲದೆ ಇರೋದನ್ನು ಕಂಟಿನ್ಯೂಟಿ ಅಂತ ಹೇಳ್ತೀವಿ, ಅಡಚಣೆ ಇರುವುದನ್ನು ಡಿಸ್ಕಂಟಿನ್ಯೂಟಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಬಟ್ ಇನ್ ಮ್ಯಾಥಮ್ಯಾಟಿಕಲ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ, ಕಂಟಿನ್ಯೂಟಿ is nothing but without break, correct? Discontinuity is nothing but has some breaks in the functions. I would like to recall and already you studied in your lower classes. ನಿಮ್ಮನ್ನು ಮತ್ತೆ ಹಿಂದ್ಗಡೆ ತರಗತಿಗೆ ಕರ್ಕೊಂಡು ಹೋಗೋದಕ್ಕೆ ಇಷ್ಟಪಡ್ತೇನೆ. ನೀವು ಆಲ್ರೆಡಿ 10th ಕ್ಲಾಸಲ್ಲಿ ಆಕ್ಟಿವಿಟೀಸನ್ನು ಮಾಡಿರ್ತೀರ. ಗ್ರಾಫ್ ಶೀಟಲ್ಲಿ ನೀವು ಒಂದು ಆಕ್ಟಿವಿಟೀಸನ್ನು ಮಾಡಿರ್ತೀರ. ದೇರ್ ಯು ಡ್ರಾ ದ ಕರ್ವ್ಸ್. ಡೇಟಾ ಕೊಟ್ಟಿರ್ತಾರೆ, ಗ್ರಾಫ್ ಶೀಟಲ್ಲಿ ಗ್ರಾಫನ್ನು ಡ್ರಾ ಮಾಡಿರ್ತೀರ. ಆಲ್ಮೋಸ್ಟ್ ಆಲ್ ದ ಗ್ರಾಫ್ಸ್ ಆರ್ ಕಂಟಿನ್ಯೂಸ್ ಗ್ರಾಫ್ಸ್ ದೇರ್. ಎಲ್ಲ ಗ್ರಾಫ್ಸ್ಗಳು ಕಂಟಿನ್ಯೂಸ್ ಆಗಿರುತ್ತೆ ಅಲ್ಲಿ. ಮೇ ಬಿ ಪ್ಯಾರಾಬೋಲಾ ಯು ಡ್ರಾನ್, ಮೇ ಬಿ ಸರ್ಕಲ್ ಯು ಡ್ರಾನ್, ಓಕೆ. ಬಟ್ ಹಿಯರ್ ದ ಸೇಮ್ ಕಾನ್ಸೆಪ್ಟ್ ಇನ್ ಕಂಟಿನ್ಯೂಟಿ. ಇಲ್ಲೂ ಸಹ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ವೆರಿಫೈ whether that curve is continuous or discontinuous at that point. ಕರ್ವನ್ನು ಕಂಟಿನ್ಯೂಸ್ ಅಥವಾ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್ ಅನ್ನು ವೆರಿಫೈ ಮಾಡ್ತೀವಿ ವಿತೌಟ್ ಡ್ರಾಯಿಂಗ್, ವಿತೌಟ್ ಆ್ಯಕ್ಚುಯಲ್ ಡ್ರಾಯಿಂಗ್, ಯೂಸಿಂಗ್ ದ ಗ್ರಾಫ್ ಶೀಟ್. ಯಾವುದೇ ರೀತಿಯಾದನ್ನು ಗ್ರಾಫ್ ಶೀಟನ್ನು ನಾವು ಯೂಸ್ ಮಾಡ್ದಲೇ, ಯೂಸಿಂಗ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಲಿಮಿಟ್ಸ್ ಆ್ಯಂಡ್ ಕ್ಯಾಲ್ಕುಲಸ್, ವಾಟ್ಸ್ ಕಾಲ್ಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಲಿಮಿಟ್. ಆ ಒಂದು ಕಾನ್ಸೆಪ್ಟಿಂದ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ಫಂಕ್ಷನನ್ನು, ಫಂಕ್ಷನ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಎ ಕರ್ವ್, ಓಕೆ. ದಟ್ ಫಂಕ್ಷನ್ ರೆಪ್ರೆಸೆಂಟ್ ಎ ಕರ್ವ್. ದಟ್ ಕರ್ವ್ ವೆದರ್ ಇಟ್ ಈಸ್ ಕಂಟಿನ್ಯೂಸ್ ಆರ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್ we can verify without actual drawing using the graph sheet, okay. Let us see what is the formal definition of a continuity. Okay, let us see the formal definition of continuity. Continuity definition: a function f of x is said to be continuous at x equals a if and only if, this IFF indicates if and only if, two-way implication, the limit extends to a, f of x is equal to f of a. I repeat, continuity definition: a function f of x is said to be continuous at x equals a. It's very important. At the point a, if and only if the limit extending to a, f of x is equal to f of a. Just observe here, very useful information is there here. Extending to a means what? Okay, the combination of x less than a and x greater than a. The combination of x slightly less than a, slightly greater than a is nothing but extends to a. X is not exactly a. X is not equal to a. That means the real number, the a, say x is equal to a, okay, is x is equal to tends to a means the x approaches slightly from left of the a as well as right of the a. Right of the a is nothing but a plus, left of the a is a minus. That means the less than a is indicated by a minus, greater than a is denoted by a plus. The combination of this slightly less than a and slightly greater than a is nothing but tending to a. So said to be continuous. Continuous means, suppose you take a continuous say at x is equal to a, I want to check I want to check whether the function, draw the function slightly less than a, and slightly greater than a, whether this function is continuous at x is equal to a or not. Without actual drawing, using the graph sheet, we can say whether the function is continuous or discontinuous using the concept of limit. Is said to be continuous, this should happen. Limit extending to f of x is equal to f of a. Let us see the discontinuity of a function. A function f of x is said to be discontinuous at x is equal to a if and only if IFF indicates two-way implication. If and only if limit extending to a f of x is not equal to f of a. Is not equal to f of a. So suppose you take for example at x is equal to a, I want to verify whether the function is nothing but a curve, is continuous or discontinuous at a. We have to take some values are there here. Okay, just to take a function. Okay, whether this function is continuous or discontinuous. Observe here, there is a discontinuity is there at x is equal to a. Is nothing but discontinuity is nothing but, so without has some break, is called discontinuous. Okay, let us take one example. Let us find the limit of f of x as x tends to 1 if it exists for a function f of x is equal to 3x minus 2 when x less than 1, 4x square minus 3x when x greater than 1. Okay, before taking this problem, again I am going to explain one important concept. Okay, there are here, as I said, x tends to a, x is slightly less than a and slightly greater than a. That slightly less than a is nothing but left hand limit. This is called LHL. Slightly greater than a is nothing but right hand limit, RHL. Okay, RHL. So now let us find the limit of a function. Okay, let us find the limit of a, this is the function, is nothing but it represents a curve. Okay, let us find what is the limit of this function. As I said, the value of a function is known limit of a function. The value of a function is known as limit of a function. So now let us take here the identification of the function which is mentioned for less than and greater than. So LHL is nothing but left hand limit. For left hand limit, limit as extending to 1 minus, because we are going to find the limit of a function at 1. This is very important, at 1. So therefore I am going to return LHL as limit as extending to 1 minus f of x. So now 1, as I said, 1 minus is less than 1. 1 minus is nothing but what? Less than 1. Let us check which function is defined for less than 1. Observe here, x less than 1. For less than 1, function is defined as 3x minus 2. Substitute here 3x minus 2. Apply the limit. 3 minus 2 is nothing but 1. Again RHL. This is RHL is nothing but right hand limit. Right hand limit is nothing but greater than 1. As I said, what? Slightly greater than a is nothing but RHL. Greater than 1. So now RHL is equal to limit as extending to 1 plus. Why I taken 1? Because we are in the problem it is given as extends to 1. We are going to find the limit of a function at 1. So therefore as extends to 1 plus f of x, this is RHL. Let us identify which function is defined for RHL. Okay, 1 plus is nothing but greater than 1. Observe here, x greater than 1 is there. For x greater than, which function is defined? 4x square minus 3. Substitute here, 4x square minus 3. So which is equal to, substitute the limit 4, whereas x is there, x square is there, 1 square minus 3, simplification is 1. Observe here, LHL is 1, RHL is 1. Since LHL is equal to RHL, that is left hand limit as well as right hand limit, they are equal, which is the value is 1. Therefore 1 is the limit of the function. In limit language, we can write the limit of a function is like this. Limit of x tends to 1, f of x is equal to 1. Okay, thank you.